After this video, you will have zero problems with visual identification of zero-order transfer function parameters. Hi, Christopher here with PiControl Solutions. In this video we will visually identify zero-order transfer function parameters with a delay. Zero-order transfer functions are also called ramp transfer functions or integrating transfer functions. In the first-order process, controlled variable settles to a new value. This is not the case with zero-order process. It never settles. Therefore, zero-order transfer functions do not have time constants. And for identification of zero-order transfer function, we need to identify process gain and dead time. Let's go to the first one, process gain or ramp rate. For every change in manipulated variable, there's a change of controlled variable, but also time needed for the change of controlled variable. Simply by dividing change of controlled variable by time of change and then dividing it by change in manipulated variable gives us process gain or ramp rate. Process gain unit is a combination of examined process variables. And for example, let's say we have change in level of 15 in time duration of 10 seconds and for a change of minus 10% of control valve. This leads us with the process gain of minus 0.15. Process gain in this example is negative because of negative change in manipulated variable. Simplest way to identify this is if changes in both controlled and manipulated variable differ in directions. More on that in next video. For the next one, let's zoom in a bit. Dead time is a difference between starting points of changes in controlled variable and manipulated variable. Usually unit of dead time is seconds or minutes. And in this example, controlled variable started at 130 seconds and change in manipulated variable started at 120 seconds of process, leaving us with dead time of 10 seconds. Let's simulate zero-order process for which we will identify parameters. For this simulation, we will use our powerful real-time online PID simulator SIMCET, made exactly as if you are tuning loops in a real plant. We will make simple step tests in manual mode to generate zero-order process for which we will identify parameters. But while we wait on our process to simulate, I advise you to check out our website where you can find all the information on SIMCET, also on our other products already used in industry as well as academia. We are worldwide leaders in online classroom and video-based training in industrial process control. So make sure to check out our training section. Now let's hold the simulation and save the data. Data is by default saved in CSV format, easily readable by any data processing application. First, we will identify process gain or the ramp rate. Change in controlled variable started at 98 seconds and ended at 218 seconds. Controlled variable went from 55 to 85% of level change and change of controlled valve was minus 5. Next, 30 divided by 120 divided by minus 5 leaves us with process gain of minus 0.05. Next one is dead time. We already found start of change of controlled variable at 98 seconds and manipulated variable change started at 96 seconds, leaving us with dead time of 2 seconds. This is it. If you like this video, share it and make sure to subscribe to our channel for more videos on process control. This is Christopher with PiControl Solutions.